Hello students, this is a video on the QA topic test at Bodhee Prep. The idea of these tests is once you go through the basic concepts of a topic, you would want to check whether you're able to apply those concepts in an exam or not. And that is when you take the test. With every test, there is a video which gives you with the solutions and a brief analysis of how the test should be taken as an exam. There are more than 200 such topic tests available on the Bodhee Prep Android app. The link for the app is in the description below. So make sure to download the app and make the most of these tests. This video is on trigonometry. This is the fourth test that we're discussing. And the test was an overall moderate level of difficulty test with about 6 questions net correct out of 10, giving you a 95 plus percentile. The ideal time to go through those 10 questions and find these 6 questions for yourself would be somewhere around 20 to 22 minutes. If you look at the questions, first question says 7 sine square theta plus 3 cos square theta is equal to tan theta. Now, for tan theta, I know that we have an identity which says 1 plus tan square theta is equal to sec square theta. So from here, if I'm able to convert this into tan and sec, I would probably be able to use this identity directly. So I'm dividing this entire thing by cos square theta. Therefore, 7 sine square theta upon cos square theta plus 3 is equal to 4 by cos square theta. This becomes 7 tan square theta plus 3 is equal to 4 into sec square theta. Sec square theta is nothing but 4 into 1 plus tan square theta. Taking tan theta on one side and tan theta terms on the other side, 7 tan square theta minus 4 tan square theta is equal to 4 minus 3, which further means 3 tan square theta is equal to 1, or tan square theta is equal to 1 by 3. Taking the root, therefore, tan theta will be plus minus 1 by root 3. Option C becomes my answer. I will call it a moderate level of difficulty question because it might not strike upfront that we want to convert it to sec. Once that happens, the question becomes pretty easy. It's just a one-step question after that. But to reach that point, we might take maybe 2 to 2.5 minutes. Tan alpha is equal to n tan beta, sin alpha is equal to m sin beta, m square minus upon n square is. Now, if we look at m square minus 1 from here, m can be written as sin alpha upon sin beta. Therefore, m square will be sin square alpha minus sin square beta. M square minus 1 will be sin square alpha upon sin square beta minus 1, which is nothing but sin square alpha minus sin square beta upon sin square beta. Similarly, if you look at n square minus 1 will become, by a very similar logic, tan square alpha minus tan square beta upon tan square beta. Now converting tan into sin and cos, this can be written as sin square alpha upon cos square alpha. It is easier to deal with sin and cos primarily. Therefore, this becomes sin square beta upon cos square beta. Further solving, you'll get cos square into sin square alpha cos square beta minus sin square beta cos square alpha upon cos square alpha cos square beta. The denominator will become inverse. Therefore, this will become cos square beta upon sin square beta. Cos square beta cancel. Further, here we can write, since the values in this equation are sines in the numerator, we convert these values to sines. So sin square alpha into 1 minus sin square beta. Cos square beta is 1 minus sin square beta minus sin square beta into 1 minus sine square alpha divided by cos square alpha sine square beta. So this becomes sine square alpha minus sine square alpha sine square beta minus sine square beta plus sine square alpha sine square beta. So sine alpha sine beta term gets cancelled. We are left with sine square alpha minus sine square beta upon sine square beta into cos square alpha. This becomes the value of n square minus 1. So if we divide m square minus 1 upon n square minus 1, m square is sine square alpha, or we can directly write from here only. This part can be written as sine square alpha minus sine square beta upon sine square beta can be written as m square minus 1 remaining cos square alpha is equal to n square minus 1, and therefore m square minus 1 upon n square minus 1 is equal to cos alpha, cos square alpha. Option cos square D becomes my answer. I'd say this is a moderate to difficult level of question. Will take some time to solve, therefore about 2.5 minutes to maybe even 3 minutes to solve the question. Another easier way of going about this question would be to simply assume value. So for example, what I do here is, I say let alpha is equal to 30 degree, beta is equal to 60 degree. And therefore, if you put the values here, tan 30, 1 by root 3 is equal to n, tan 60 is root 3. So n becomes 1 by 3. Similarly, put the values here, sine alpha, sine 30. 1 by 2 is equal to m times sine 60, root 3 by 2. M becomes root 3, 1 by root 3. Put the values in the equation required, 1 by root 3 whole square. So 1 by 3 minus 1 upon 1 by 9 minus 1, n square. This becomes minus 2 by 3 upon minus 8 by 9, which will be 2 by 3 into 9 by 8, which is nothing but 3 by 4. 3 by 4 is root 3 by 2 whole square. Now here the values are alpha. Only for one of the values, that is cos 30. Is the value root 3 by 2. And therefore my answer simply becomes cos square alpha. Again, putting values will also give you the answer and it will be much faster to solve. Sec A is equal to A plus 1 by 4 is then sec A plus tan A. There is a direct relationship between sec A and tan A, that is sec square A is equal to 1 plus tan square A. So if we find out sec square A, we'll be able to find out tan square as well. So from here I can say sec square A is equal to A square plus 1 by 16 A square plus 2 into A into 2 into A into 1 by 4. A and A cancel, 1 by 2. 1 plus tan square A, this becomes 16A square. And therefore tan square A is equal to A square plus 1 by 16A square. 1 by 2 minus half is minus 1 by 2. This can be written as A square plus 1 by 16A square minus 2 into 1 by 4A into A. And therefore tan square A is nothing but A minus 1 by 4A whole square. Therefore tan A, depending on which quadrant it is, would be plus minus of A minus 1 by 4. Now there are two cases possible. When tan A is A minus 1 by 4A, in this case sec A plus tan A would be A plus 1 by 4A plus A minus 1 by 4A, which will give us the value as 2A. This is case 1. Case 2 is when tan A is minus a minus 1 by 4. In this case, sec a plus tan a would be a plus 1 by 4a minus a plus 1 by 4a minus 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 plus. This will be 1 by 2a. And therefore, two options are possible. Either 2a or 1 by 2a. Option A becomes my answer. Even this question I'd call definitely a moderate level of difficulty because it is very easy to miss out on one of the positive or negative values and get a wrong answer. Value of sine cube a plus cos cube upon sine a cos a plus cos cube a minus sine cube a upon cos a minus sine a. Again, we use the identity for a cube plus b cube. It is a plus b into a square plus b square minus ab upon sine a plus cos a. This will get cancelled. Similarly, for the second one, a minus b, a cube minus b. So a minus b into a square plus b square plus ab upon cos a minus sine a. Again, this gets cancelled. So we are left with sine square a plus cos square a minus sine a cos a plus cos square a plus sine square a plus sine a cos a. Sine a cos a plus and minus cancel out. Sine square a plus cos square a is 1, cos square a plus sine square a is 1, therefore 1 plus 1 value becomes 2, option C. Again, this I'd say is an easy to moderate question, direct application of a cube, b cube, a cube plus b cube, and you get the answer. So about 1.5 minutes to solve. The value of tan 20, tan 40, tan 60, and so on. So the first angle is 20 into 1. The last angle is 20 into 9. So there are 9 terms. What are these terms? Tan 20. And on the extreme side of it would be tan 160. Tan 40. Tan 140. Tan 60. Tan 120. Tan 80. Tan 100. And then we have tan 180. These are the 9. 20, 40, 60, 80, 100, 120, 140, 160, 180. Now, if we add these two terms, tan 60, tan 160 can be written as tan of 180 minus 20. Tan 20 remains as it is. This becomes tan of 180. So tan remains tan. 180 minus 20, second quadrant. So this becomes minus tan 20. Therefore, this plus this will be 0. Similarly, this will be tan 40 minus tan 40. 180 minus 40. So the sum of these two will also be 0. Similarly, the sum of these two will be 0. Sum of these two will be 0. And we know that tan 180 is 0 in itself. And therefore, two terms at a time, 4 pairs will add up to 0 and tan 180 is 0. And therefore, overall answer will get as 0. Again, easy question. Not more than a minute and a half to solve. Cos theta is minus root 3 by 2. Theta does not lie in the third quadrant. Since cos theta is negative and theta is not in the third quadrant, cos is positive in the first and the second quadrant. Cos is positive here. Theta is not. So theta has to lie in the second quadrant. Alpha lies in the third quadrant. So here only tan is positive. Sin alpha is minus 3 by 5. Tan alpha, tan theta, cot theta, cos alpha. Now since cos theta is equal to minus root 3 by 2. Minus root 3 by 2 means 30. Sin theta. So basically this becomes perpendicular. So this becomes base, this becomes hypotenuse. P square plus B square is equal to H square. So P square is plus 3 is equal to 4. P square becomes 1 or P becomes 1. Therefore, from here we can say sin theta in the second quadrant will be 1 by 2 And therefore tan theta in the second quadrant will be sin theta upon cos theta, or minus 1 by root 3. If we look at alpha, sin alpha is minus 3 by 5. Cos alpha therefore will be 4 by 5, minus 4 by 5, because sin square alpha plus cos square alpha is 1. 5 square is 25, so 9 plus 16 is required. And tan alpha in the third quadrant positive will be sin alpha upon cos alpha, which is 3 by 4. Putting the values 2 into tan alpha 3 by 4 plus root 3 into tan theta minus 1 by root 3 upon cot square theta. Cot square theta will be the inverse of this. So cot theta will be minus root 3. Cot square theta will be 3. Cos alpha. Cos alpha is minus 4 by 5. This becomes 3 by 2 minus 1, 3 minus 4 by 5. 3 by 2 minus 1 is 1 by 2. 15 minus 4, 11 by 5. And therefore, the answer becomes 5 upon 22. Option A. I think moderate level of difficulty question. We just have to find the values of the angles, which might take some time, otherwise conceptually not difficult. Cos 36, 55, 125, 216, 300. Cos 36 remains as it is. Cos 55 remains as it is. This becomes cos 180 minus 55. This becomes cos 180 plus 36. Cos 300 is cos 360 minus 60. Cos 36 degree remains as it is. Cos 55 degree remains as it is. Cos 180, so cos will not change. 180 minus 55 is second quadrant, so negative. Minus cos 55. Cos 180, so cos does not change. 180 plus 36 is third quadrant, cos is negative. Minus cos 36. Cos 360, so cos does not change. 360 minus 60 is fourth quadrant, so positive. Cos 60. This and this cancel, this and this cancel. The answer is simply cos 60. And cos 60, the value we know is 1 by 2. Option A. I think easy question, not more than a minute and a half to solve. Cot theta cosec theta plus 1, cot theta plus cosec theta minus 1 is equal to, when we look at cot theta cosec theta, we know that cot square theta, or rather cosec square theta minus cot square theta. This is equal to 1. 1 by sine square, cos by sine. 1 minus cos sine, yes. So what we can do is, we can break down this 1 first in terms of cosec and cot and then work from there. So cot theta minus cosec theta plus cosec square theta minus cot square theta. 1 I have written as cosec square theta, cot square theta upon cot theta plus cosec theta minus 1. Now cosec square, cot square, a square minus b square can be written as a plus b cosec plus cot into a minus b. Cosec minus cot upon cot plus cosec minus 1. Now from these two terms, that is, this is the first term, this is the second term, we are taking out cosec theta minus cot theta. Cosec theta minus cot theta we are taking out. Cosec theta minus cot theta, common. So here we'll be left with a minus 1, because this is cot theta minus cosec theta. And here we'll be left with cosec theta plus cot theta. upon cot theta plus cosec theta minus 1. As you can see, these two terms are the same, and therefore remaining we have cosec theta minus cot theta. So the answer becomes option C. Overall, I'd say maybe a moderate level of difficulty question, but it is important that we are able to break the one. Otherwise, we'll convert this into sine and cos, and that can take a bit of time. If that also does not work, then take a value of theta and then try to match answer the options. That could be the last way or a different way of solving the question. Alpha lies between 90 and 180. 91 is second quadrant. Sine alpha is root 3 by 2. Cos alpha, therefore, will be 1 by 2. Sine square alpha plus cos square alpha negative. Because second quadrant. Tan alpha will be sine alpha upon cos alpha, which is minus root 3. Beta is 180, 270, third quadrant. Sine is negative. Cos will also be negative. Tan here will be positive. Sine upon cos. Putting values 4 sine alpha. 4 into root 3 by 2. Minus 3 tan beta. Minus 3 root 3 upon tan alpha. Minus root 3 sine beta. Minus root 3 by 2. This becomes 2 root 3 minus 3 root 3 upon 1 minus 1 by 2 minus 3 by 2 root 3. So minus root 3 upon minus 3 by 2 root 3. Root 3 cancel, negative cancel. So 1 upon 3 by 2 or 2 by 3 becomes my answer. Easy question, just finding the values and putting in the expression, about 1.5 minutes to solve. 1 plus cos theta upon 1 minus cos theta under root plus under root minus 1 minus cos theta 1 plus cos theta is equal to. Again, first of all, take the LCM. Root 1 minus cos theta into root 1 plus cos theta. This gets cross multiplied. Root of this into root of this will be 1 plus cos theta. Root of this into root of this. Root of A into root of A is A. So plus 1 minus cos theta. This becomes cos theta cancel 2 upon root of A minus B into A plus B is A minus B square. Or A square minus B square. 2 upon root of 1 minus cos square theta is sine square theta. And root of sine square theta will be nothing but mod of sine theta. Depending on where theta is, we might get a positive or a negative sign. And therefore, option D becomes the answer to this question. Easy question, straight for multiplying. Taking LCM and multiplying. From there, it's just one identity. So not more than a minute and a half to solve. So if you look at the overall test, difficulty level was moderate and we were looking at 6 questions for our percentile. For me, they would be 4, 5, 6, 7, 9, 10. Which are these? I'm not counting these questions as short questions because every time the arrangement may not be possible. But from here, I'm counting questions because this is a basic identity for A cube plus B cube. Putting values, solving, finding the values and solving, putting values and solving. This could have been a little tricky, so not counting it as one of the 6 easy questions. Again, finding the values. This was an easy simplification. So for the 6 questions, I would look at 4, 5, 6, 7, 9, and 10.